When I entered the classroom a little over a decade ago, I had all of these ideas about the rich discussions we were going to have day in and day out, and yet reality struck me like a brick across the side of my face on that first week, and it all went to, I can't say that word up here. But I got my bearings over the next couple of years, and with some encouragement and support from colleagues and mentors and folks on the internets, I decided I would give this discussion thing a try. We weren't going to do the rows, we were going to have discourse. It was going to be beautiful. This is an artist's rendering of what the discussions actually were like in my classroom during that time. It wasn't that beautiful, but it was a start. And I took another leap forward when I read this delightful book, The 5 Practices. Yeah. I actually scheduled for 14 seconds of applause on this slide, so we need to keep going. If you're not familiar with the 5 practices, anticipating, monitoring, selecting, sequencing, and connecting. Now, in their preface, they just floored me immediately, right out of the gate. I read this account of a classroom experience and exchange, and I thought, that teacher is who I want to be when I grow up. And then they tore him a new one and said that's not what it's supposed to be like. So here I am on the stage with a confession. I love the 5 practices and an apology. We have 13 slides left, and I'm going to try to do way too much with them. Are you ready? Yeah. All right, fantastic. I work for a company called Desmos. We build math tasks and technology. This is one of my favorites. Yay, Desmos. It's called Pool Border Problem. It's a tried and true task with a little bit of Desmos technology sprinkled on top. One of the things you might do is anticipate your goals for this activity and anticipate what students might do as they move through the activity. As they think about different ways of counting the number of tiles around the edge of the pool, what might they see? How might the structure appear to them as they're viewing it? They might scribble sketches on there, and you might, as a teacher using Desmos tools, monitor their work in the teacher dashboard as it streams in. You might look at some of those interesting drawings and you might want to draw them into a discussion. So you might select some of their responses by mashing that delightful little camera icon in the top right. Maybe I want to take some of the ways that students have described what they saw, right next to how they sketched what they saw, and then I might actually want to hide the drawings, select 4 of the ways they described it, or 4 different groups or students in the class, big square minus little square, 4 groups of 6, so 24 total, 5, 5, 5, 5, and then 4 at the end, or 7 on the top and bottom, and 5 on each of the sides. And I might want to serve those up to the students in the rest of the class and invite them to engage with their classmates, their mathematical colleagues' ideas. Pick one and draw what you think they had in their mind as they described it this way. Or I might want to make a connection in a different way. Serve up one of the drawings and invite students to write an expression. How do you think your classmates saw this? What mathematical expression, what numerical expression could help us see what they saw? And then on the next few screens of the activity, we're going to look at a 10 by 10 pool, a 13 by 13 pool, 16 by 16, and where are we headed? We're trying to build from numerical expressions to an algebraic one. So I might hop back into monitoring mode in the middle of class, hunting for student work and trying to select, sequence, and surface that so that we can make connections. I noticed that this particular student nailed it on screens 4, 5, and 6. So I clicked to drill deeper, and I see the expressions that that student used, and I thought, I can use that student thinking and help weave a mathematical story that gets at the goals that I had in mind when I was anticipating back at the beginning. And so I select some of those, sequence them, serve up that collection, and invite students to make connections. 10, 13, 16, what about 20 by 20, 30 by 30, 42 by 42? Or, as we're moving into the next one, n by n. Let's build from numerical and generalize with algebra. Or maybe students saw it this way, the big square minus the little square. I can play that same game. Or I might want to ask them, no, there's no time for that, let's move on to this. Or I might want to serve up several different algebraic representations. Invite students to discuss with their classmates which of these student responses are correct. How do you know? Which of these expressions are equivalent? Can you actually prove that? Or, since there wasn't quite enough time to show off everything I wanted to show you, maybe if you're intrigued by this idea of Desmos and snapshots, selecting, sequencing, and connecting, you can learn more at this lovely website.